Now let's look at something else which is equally powerful as the rest that you learned already. That is how you can actually transfer Ether to a smart contract and back again. Now over here, we have still our sample contract, and I want to extend it a little bit by letting somebody overwrite that string if we are paying 1 Ether, or maybe 0.1 Ether. Now there's two things that you should know for that. The one is a payable modifier, and the other one is a property of the public message object called value. Let's start with the first one, that is the payable modifier. Let me show you what I mean. I'm here in the deploy and run transactions tab, and I selected the JavaScript VM again because it's much easier to work with. We have our accounts with 100 ETH each, and I'm going to deploy the smart contract. Now over here, when I hit the update string method and I just write something inside, I can hit update string, and then the string will be updated as we know from before. Now, when we open that transaction details, then you see that our value is 0 way. Now I can also send some Ether or some way or some value to the smart contract with the same transaction. And I can do this by modifying the value field here. And in in MetaMask, you can do this also by adding ETH to a transaction. Let's change this by adding 1 Ether from the dropdown here and send this to the smart contract. How do you send this to the smart contract? You don't really have to do anything. You just have to enter a value here and then send off a transaction. Now, if you're doing that, it will fail. And the reason for that is that we have to mark functions that are meant to receive ETH with a payable modifier. And the payable modifier comes here, public payable, it's defining this function as a function that can receive ETH. And if we are deploying this again, then our button here becomes red, meaning as a UX, simply a UX thing, that this function is meant to receive ETH. Now it doesn't need to receive ETH. You can still write here ASDF and send something without any value. But now you can also send one ETH together with that, and it will still work. Now the value is 10 to the power of 18 way, or 1 ETH, and it's still overriding it. And it's not erroring out. Now we're not doing anything with those ETH. Instead, this 1 ETH is now stuck in the smart contract, and as long as we're not sending it away, it will stay there forever. Now we have locked 1 ETH in our smart contract. How can we get it out again, and what can we do with it? Now the one thing is the message value. If you want to know how much ETH or what kind of value was sent to the smart contract, then you can access the message object, the global message object, and the value property. Let me show you what I mean. Let's say we want to have at least 0.1 ETH, or let's say we have at least 1 ETH to change this string. So if message value is 1 Ether. Ether is a global unit. It's a globally available unit like Gwei. There's a couple of them, and I will show it to you later in a presentation and also on our website. But for now, you can just safely assume that Ether, that is already defined somewhere as 10 to the power of 18. If that's 1 Ether, then just update the string. So if we are deploying that, deploy the smart contract, write ASDF without anything, it's working, but our string is not updated. And the reason is because we didn't send 1 ETH. If we send now 1 ETH, then our string gets updated to ASDF or any other test string ASDF might not be the best test value, but I hope it shows you enough about how this thing works. Now, the problem is if we are sending, let's say, 1 GUI, the transaction still works. We sent a value there, but now our smart contract didn't error out or did anything. So we basically just sent 1 GUI there, but didn't get it back, even though nothing changed here. So let me just hello you, put in 1 GUI, send this. Doesn't update, but the transaction works. So now we already sent 2 GUI there, but how can we get it out again? Now this is where we can actually send money or send ether from the smart contract that is stored inside the smart contract back to an address. And that is not any address, it must also be a payable address. And if we just make something like this, there's 2 options here. Number 1 is we let it error out, but we didn't learn anything about errors yet. So let's just send it back. Else, and you already know this, the message sender, that is the address that sent the transaction in the first place. .transfer message value, and it doesn't like it because it's only available for types address payable, but message sender is just an address. So we have to wrap this in a payable casting modifier. So now we have a payable address over here, and every address, every variable of the type address has a transfer function. And this transfer function will transfer from the smart contract the value to the address. Now the smart contract can take care of his own money. So you can send money to the smart contract. It can be stored there. There is nothing that the logic itself needs to do. It's just natively on the EVM level, and it can send it back. So let's give this a try. So let's say we are deploying the smart contract, but instead of just sending 1 ETH, we are actually sending 5 ETH. And that should have a major impact. Hello global. So the transaction goes through. We send 5 ETH there, but we don't have 5 ETH less. Instead, what happened is we sent the 5 ETH there, and it was immediately in the same transaction sent back without us doing anything. Yeah, and just to recap that, we are going to learn more about different structures, how you can let it error out properly, how you can require certain values and so on. But in general, these are the 2 most important global variables that you will probably encounter during your Ethereum blockchain developer career. That is message sender, the address that sent the transaction, and message value, the amount of ETH that was sent within the transaction to the smart contract. Now the payable modifier is here to make a function allowed to receive ETH. Now what happens if you're actually sending ETH to the smart contract without calling any function? Basically just making a transfer. That's where the fallback functions come in, and that's what we're doing in the next video.